Okay, cool. So this is a great introduction, but not just a great introduction to TensorFlow, but also prompt engineering. I'm an old guy. I've been around for a while. I teach for Microsoft from time to time. I have 23 cloud certifications, a bunch of industry certifications. I am a avid hacker, so I typically could participate in a hackathon every week. I've run about 22 such teams, and we've run about five hackathons, which is really, really good. If you win one, it's considered to be like really amazing, and then you win because you're competing against globally against thousands of people. So you win five, it's a good thing. So, and I'm getting better at team management. So that's one of the things I really want to get into, running small teams under short time periods and and accomplishing as much as you could. And I have something I call the 5 C's that I do to run those. With that said, what's coming up here in the future is we've got getting started with TensorFlow, of course, today. NVIDIA is going to be on CUDA. That's on the 20th. That's actually on a Saturday. That's an hour and a half. And that's going to be going through their data analytics piece. Then everything RAG's coming up, a review of the graph RAG. So there's a lot of different graph RAG systems out there. Everyone's talking about it. And so we'll do a graph RAG review. And then mastering Terraform with prompt engineering. So for the rest of your days, at least for the next few years, you're going to hear about prompt engineering from me because this is what I do constantly now. And it's extremely productive. Welcome to the AI arms race, folks. Yes, we are in the AI arms race. Companies are pouring billions, just billions into AI, and they're just competing. And with that said, really an honor because we're in a different time in history. We've seen stuff like the agricultural revolution, the industrial revolution, which my parents were involved in, the scientific digital revolution, which I was involved in, and then now we've got this what's called machine learning revolution, but even more than that, generative AI revolution. And each time we hit one of these revolutions, the amount of progress that is made exponentiates, and we're headed toward um, AGI, and then after AGI, there's ASI, which is artificial superintelligence, where machines are making Nobel Prize discoveries every 2 to 3 days. So it's an exciting time to be alive, and some people are a little bit nervous about it. I can understand why. Uh, Generative AI today will buy you about a 10,000% efficiency in your workflow. Here's an example of Dentons, which is the world's largest law firm as far as people is concerned. And it used to take them 4 hours to do a brief, and now they can do it in 5 minutes using a vector database. That's amazing. We've been doing a lot of generative AI over the past year and a half, but we're now entering into what I call the year of devices. You're going to start seeing a lot of these devices come out. Gemini's glasses are out. The Copilot computers come out. We're hooking all this stuff together to work and learn. So it's kind of doing stuff that we never thought was possible. And with that, we're going to start our icebreaker today. And in the icebreaker, we want to know what futuristic technology, once considered sci-fi, has AI made possible today that has most surprised you and why? And I have to tell you, if you watch the old Star Treks, right, or Voyagers, and they have all this advanced technology, and this is what's supposed to be 2,000 years from now, you go, oh my goodness, we're doing that now and better. It's just stunning. So, what has stunned you about AI? What is being done that was you thought could only be done through sci-fi? And you can answer or you can put it in the chat and tell me why. Which one of those? Self-driving cars, personal AI assistant, robotic surgery, smart homes, text to video, facial recognition, virtual reality, real-time language translation, human-like robots, AI generated art and music, or some other aspect of AI. What has just, knocked your socks off that AI is doing that you never thought it would be able to do? Stuff of sci-fi movies of yesterday. One of the things that I think that AI is really blowing the doors off is education, the way we learn. I mean, we now have the ability to tailor our education system individually, where we haven't been able to do that in the past. In the past, we've used something called a push system. So if you're an old Scrum guy, Agile guy, when I say push and pull, you understand what I mean. And push is where you push work on somebody. And so the way we actually ran education systems is we have a classroom of people. We have a teacher stand up. We try to make the slow ones move faster and the fast ones move slower and homogenize everything, right? So it's pretty brutal. And we push work on them and believing that will cause them to learn. Now, today, we have the ability to pull work, create systems where we're actually pulling and we're discovering, and then we're getting what we need when we need it. And I call that education on demand. And we're going to see a bunch of that today. Additionally, I want to make a few comments about how we'll be prompting. In the past, we used AI for classification systems, and we would classify this object or that object. And what has happened is these classification systems through generative AI have captured our reasoning. So you not only understand what we chose, but why we chose it. And if you're working with AI, and we'll see this a lot today when we build our prompts, it works really well with a goal. And from that goal, you come up with an algorithm. And from that algorithm, you grind out details. And if you give it a format to follow, it will follow that format. Now, one of the things I want to say, if you've given it a goal and it's ground out an algorithm or a recipe, many times it already knows the content of that recipe. And we're going to use that technique quite a bit today. What I'm talking about and proposing, of course, is just-in-time learning. And what that gives us the ability to do on an individual level is reinforcement learning. And so you have to think about it, like how does someone become like a virtuoso? Is that coming from outside in or inside out or a combination of both? And then we have the ability now to create these tailored educational pulse systems. You'll experience that today. Well, in today's presentation, most research starts with Python, but to get it into the browser, we need JavaScript. So we're going to examine TensorFlow both in Python and in the browser. So I'm going to start off with my first prompt. So I'm going to be prompting the whole class today. And what I want to know is what is Keras and what is TensorFlow? In the old days, I'd have to go off and, watch a video or watch a YouTube or register for a course. But I don't need to do that anymore. I just bring up my prompt and we'll go to GPT, sorry. And we'll go, what is Keras? What is TensorFlow? And you type that in, and you guys can follow along if you want. You should get your Chat GPT out, or you should get your Claude AI, which is free. And it's going to give me a whole explanation of Keras and TensorFlow and everything I wanted to know and more than I wanted to know. And then it's going to give me example code. Isn't that pretty amazing? That I can actually run in Hugging Face. So we're going to do a bit of this today, but pretty much Keras acts as an interface for TensorFlow library. It is designed to make deep learning accessible and approachable for people who are new to machine learning. So it actually makes it easy to program the classes. So when machine learning first came out, there were a lot of classes that you needed, packages that you needed to run it. And so TensorFlow was what was created first by Google. So TensorFlow is an open source library developed by Google Brain team for machine and deep learning. It provides comprehensive, flexible ecosystem of tools, libraries, and community resources that lets researchers push the state of the art in ML, but Keras rides on top of that and allows you to easily manipulate and program TensorFlow. And here's kind of a stacking diagram. We won't spend a lot of time on it, but you can see here's the Keras, API, and below that are all the tensor layers and losses and metrics and so forth. Let's go right into the brain. So we're trying to create systems that work like the brain, and we call that a perceptron. And so if you look at a neuron, it has all these dendrites and then all these connections on the outside. So we've linearized it. And so we call it a weighted sum. And it really is just a linear equation in multidimensional space. So if you look at this, each one of these are weights and you have inputs, and the inputs can be weighted differently on what the feature set might be. So, but if you look at it at the end of the day, this turns out to be just one large matrix equation. With that said, we're going to actually start with exercise 1, and you guys are going to play around with building a neural net, and then we're going to prompt engineer something right from it. We're going to reproduce this entire image using TensorFlow. So let me go ahead and grab this ID. I'm going to let you guys go in there and play around with TensorFlow. You can follow me along, but this is your first exercise. Yes, this is a hands-on class today. You guys see the playground link?
Yes.
Okay, so go ahead and open up your browser, and we're going to go ahead and look at a few of these real quick. And this is an example of a neural net. And so basically what happens is you have these inputs, and these inputs make all possible combinations, but some of them are stronger than others. And then you have your output. So what you're trying to do is get these neurons by weighting these different inputs and connections to distinguish between the orange and the blue dots. So if you run this one was pretty easy. Okay. Then it gives you another condition where you can run that one. And that's a little more difficult. And then you can run the next one. And that one is pretty easy, but the last one's not so easy. And so if you really want to get your system to be able to divide those two, you're going to need to add more layers. And so you're adding more layers. And then you're going to need to add more neurons. And there you go. And so now you added more layers and see there's more connections going on and it's weighting. You can see the ones that are becoming thick are the most important ones, and the ones that are becoming thinner are less important in the actually division. And you see with those neurons, it's beginning to figure out the difference between the two. And it will take it a while as it begins to grind through. And we say each time it runs an epoch. It's running data. So it's got training data that's going in, it's training the system, and it's doing a back propagation to adjust the weights. And you can see it's struggling there a little bit, but it's doing better than it was. And so I won't spend a whole lot of time on this, but I'm going to go back to the original example. Just want to give you guys a feel for what's happening with these neural nets. We're actually going to build this. Go back to the original and go back to the original example. And all I want you to do is I want you to take a screen capture of the screen. And what you're going to do is you're going to put that into your chat GPT or your Claude AI, and you're going to use this prompt. Create a Keras TensorFlow program that does what is in the image. Put a Streamlit interface on it for user interaction, input and output, and use matplotlib where appropriate. Create any required synthetic data. So what I'm going to do is put this prompt in the chat so you guys can use it. And we're actually going to watch it make this actual thing. This is pretty amazing. So what I'm going to do is bring up my prompt. And so what this actually shows a change in the technology. Because what I used to have to do is put an image in there and say, now give me the text from the image. And now with that, let's create a prompt. But now I just put the image in there and just read the image. And so it just automatically reads the image, and I'm interacting multimodal with whatever comes along. So I'm going to grab that image, which I took a screenshot of. So I'm going to take there, I'm going to paste that image in there. And then I'm going to take, so that's the image. And now I'm going to take that prompt and I'm going to paste that prompt in there. And it's going to create that program. All right. So it's reading the image. And not only is it reading the image, it's looking at what it built. And it's reasoning what it's supposed to build. This is absolutely incredible. And so if you're a scrum master and you're used to running teams, and you get your team together and you draw something on the board as you work out the details, and then you send your team off to build it, you don't need to do that anymore. Just take a snapshot of what you drew on the board and tell it ChatGPT or whatever system you're working with to build it. And you can see it actually cranked it out. Now, you want to run this. So this is a Streamlit. What Streamlit is, it's an interface that lives on top of Python, and it allows you to create a web interface from Python to the world. So I'm going to show this to you, and I'm going to give you the link for this. So let me go to my Hugging Face. And my Hugging Face has tons of code. So I recently ran this code. I don't think I made any changes. And I put it into this TensorFlow class I have right here. So let me TensorFlow class. Let me go ahead and put this in the link so you guys can go to it. Prompt example. That's the example that we did. This is what it created. And what it gave me was a learning rate, an activation function, the number of hidden layers. Remember, we could adjust the layers when we worked with the playground. The neurons per layer. Isn't that pretty amazing? And the batch size and the number of epochs. And guess what? It reproduced it. That is just incredible. Ha! Just what? I mean, look at that. And so if you want to see my Hugging Face, well, how was it built? I mean, you can see it's the same code that I pulled from that I created. So you can go here to Files, and you go to Pages, and if you look for that prompt example, there's the code right there. Pretty amazing. Just by prompting. And I was just like, wow. Just by taking a snapshot and prompting what you wanted from that snapshot, it built it. Pretty incredible stuff. So you guys can go ahead and try to build that if you want, but I just want to show you the prompting. We're going to get more into prompt engineering today as we move along. But that's just, if you didn't know how powerful prompt engineering was, or you had just missed what's happened. I mean, with ChatGPT 4.0 and on now Claude 3, Claude, 3.5, everything has just really, really changed. And now I guess GPT-5 is just around the corner, and that's going to give you PhD level coding. So let's go to the next exercise. So we're going to go to prompt 3. And that exercise, this is what I'm saying when I talk about pull education. So I run, did you have a specific question about what you're seeing in the playground? What you're seeing is basically these are neural nets. It's a neural net, and it's solving to differentiate between two different, could be flowers, for example, different types of flowers, or different, in this case, different colors. Okay, cool. All right, with that said, lots of times, I think that our idea is we have to, in a sense, sign up for a course to learn or watch something on YouTube to learn. And those aren't bad ways to learn. But now with this type of technology, you can prompt your learning. You can have learning on demand. And so what I want to do is I want to create a course that has 10 possible examples in it that I can learn hands-on with. And so I can tailor that course for a specific type of technology for what I want to learn. But what I'm going to start with is create a Keras TensorFlow course with 10 hands-on exercises that will help me learn Keras and TensorFlow. Take me from zero to hero. And so as you concentrate on individual exercises, add the Streamlit and Matplotlib functionality. So let's start with the first one, and let's generate our own course to learn from. So let's go bring up ChatGPT. Now you can do this in Claude. So let me show you both. Claude AI is free. So if you go to claude.ai, we can go ahead and put that prompt in there and run it, and it will generate a course for you. Now, one of the things that Claude AI does now, which is superior to ChatGPT, is it has an artifact window. And from that artifact window, it can actually plot HTML and JavaScript files that you create. It's pretty amazing. And I think I demonstrated that in another one. It says, I would like to outline the course with a brief description of each exercise. Would you like me to start creating? Yes. Yes, I would. Okay, so generate a course that I can actually learn. And I may be interested in, let's see, exercise 7. Give the details of the code for exercise 7. And it's going to crank that out for you, which is pretty amazing. I mean, just wow. And this stuff runs out of the box. I mean, I'm not running into a lot of errors. And if I do have an error, what I do, I feed the error back and say, fix it. And typically it fixes it. Let's go to the same exercise in ChatGPT. And once again, I mean, guys, if you're a learning and development guy, you should be blown out of the water by now. I mean, you have no idea how many hours of work it takes to do something like this. And not just out of the box, you do a return here, a 0 to hero. I mean, that could be weeks, if not months of work. And suddenly you have it right at your fingertips. And it's actually, in this particular one, it's actually going to give you code for each example. There you go. Building convolutional neural network, CNNs. Once again, TensorFlow and Keras. You can see the TensorFlow and Keras. You have your training and your test sets. Building up your convolutional neural network right there. Data augmentation. And those 10 exercises, here's recurrent neural nets. You're just building your own curriculum. Now, what can happen, let's pause, let's stop it right here. And let's say I'm really interested in recurrent neural nets. So, and I don't really understand all this code. So copy this code, right? And you can say, explain this code to me. And it's going to go through now and it's going to explain this code kind of line by line, what each line of the code is doing. So you may spend lots of times, if you got a bug in code or you don't understand a piece of code, you may spend a lot of time going through Stack Overflow trying to figure something out. You don't need to do that anymore. You can just type that in, explain this code, and it'll explain it to you line by line. Annie says, does Claude AI generate your Word document? Let me see, Annie. Let's see if it does that. It may do that. So give this to me in a Word document. It says it can. And there you go, Annie. Oh, wow. That's wonderful. I'm glad you showed that to me because now I don't have to copy and paste everything. I can just put it all in a Word document. So Annie, yes, it does give it to you in a Word document. And also here's the download button right here, Annie. You can just download the file once it's done. Oh, so we've generated our course and we're ready to start learning. So let's go to the next step. And then what I want to talk about is when you generate that code, you want to put it up in Hugging Face. I want to talk about the structure that will help you build this type of code, specifically Python and Hugging Face. And what I'm saying is there's a structure here. And if you see, I have an app structure, that's my top layer structure. And underneath that structure, I'm going to have my pages. So you can create an app and then you can create pages and just keep sticking all your code into those pages and it'll arrange it for you. And then you need to make sure you're collecting your requirements file. What is a requirements file? A requirements file are the basically the packages you need to bring in to make the code run. So let me show an example of a requirements file. Say I'm back in ChatGPT. I asked it to explain this one to me. I'm going to ask it what files or packages do I need for my requirements file? And it's going to tell me. I mean, this is pretty amazing. I don't have to fish around or have an error. I just ask it what I need, and it says, well, you need TensorFlow, Streamlit, Matplotlib, NumPy, and scikit-learn. My 10 exercise course, let me bring that up, is in Hugging Face. And there it is right there. And I have an outline of what it gave me when I prompted it, and I came over here and started building those. But what I also added to the course was NumPy examples and Pandas examples. Once again, every single line of code that you see here today was prompt engineered. I did not write one single line of code. And so if I go to NumPy exercises, it gives me the so you need to know NumPy and Pandas. Those are supporting technologies for TensorFlow. That's why I had these two in here. So you come along here, well, let's create a 1D NumPy array. So you run the example. There it is. There's my output. Oh, let's create an array with a range of values from 0 to 9. I create that. There it is. Shows you how to do that. Go to next one, create an array with evenly spaced values using line space. And let's do that. And then you're going to come along here and say, well, let's slice an array, or let's have a fancy indexing array. Let's do Boolean arrays. Let's do element-wise multiplication. Once again, easy to do. And then finally, sum of all arrays. And so it goes on and gives you 20 examples. You could add 50, but it gives you 20 important examples. Let's take a look where you get a matrix. Let's generate a 3x3 identity matrix. And when we look at that, and there's my identity matrix. Now, I may not understand this code. So if I don't understand what it's doing, I just copy it. And I go back to ChatGPT and I say, explain this code, or just explain. And I can use 3 dashes and just paste it in, and it'll go through there and explain that code to me. So all the time that I've spent moving, going from place to trace, trying to figure out how things work, reading books, watching videos, I don't need to do that anymore. I can have learning on demand and pull that and go, whoa, that's good. Maybe I want more examples. Give me more examples on how I can use this. And then you can take this code and you can put it up in a Hugging Face and run it in Hugging Face. So immediately, as opposed to me watching a video, me having to go through all the Stack Overflows, immediately I'm coding. I'm immediately coding. I'm not setting stuff up or even setting up a coding environment. I'm using an environment that's already there, Hugging Face, which is free. And if I get an error, I just feed it back into ChatGPT and ask it to fix that error. So the way you can do and work and learn these different topics has really accelerated. I want you guys to do an exercise, and that's create a logistic regression neural net. I'm going to show you an example of what I expect you to create, and we're going to walk through this exercise together. Okay? So on Hugging Face, I created a logistic regression neural net. And basically, well, what the heck is that, right? I don't know what that is. Let's see if we can figure it out. So let me come up here and go to logistic regression neural net. And what this neural net is doing, this is a famous data set, by the way. It's the iris data set. It has these two flowers. It's trying to distinguish one flower from the other. And these flowers have distinguishing parameters. Like, for example, the sepal length for the iris setosa is 5.1. For the iris versicolor color, forgive me, I can't pronounce these, is 7. So you can see right here, if you get a measurement of 5 and you do a prediction on that, it's going to predict it as the setosa. But if the number here is 7, for example, there you go, varicolor. So it did a nice prediction for me, and this was all of this was created through prompt engineering. I did not write single line of code. So if you take a look at the files and you go back to pages and you look for logistic regression, there you go. Click on that, you can see that code right there. And that is only 142 lines of code, but it's powerful. It actually trains that model and then it does the production of that model, which is pretty amazing. All right. So, I mean, so let's see if we can build this. So let's go back to our slide here and let's see if we can start prompt engineering it. What is the first thing you think I need to ask it if I want to create a logistic regression neural net? Where would you want to start? Okay. This is our next exercise, exercise 2. Guys, tell me where you would want to start to build this logistic regression neural net. What's the start? What's the starting point?
Panel size?
Huh? Pedal size? Let me make something even simpler. I'm gonna say something even simpler. What is what is a logistic uh regression? NN. What is it? Right? I don't even know what it is. So you got an input layer, you have an output layer, and it's gonna, oh, what is saying? It's a Boolean, right? It's gonna be 0 or 1. So basically, what it's going to do is, as opposed to continuous values, it's a classification system. Oh, well, that makes sense. And it's going to give you the math for a classification system and using something called a sigmoid activation function. I didn't know that. What does that do? And so you can go in and ask it, what does sigmoid do? And what sigmoid will do, it will give you the ability to take a linear response and turn it to a yes or no. And look at that. It's actually going to give you an example. I mean, this is pretty amazing. So at this point, that was one question. So I just asked, what is it? Okay. Anyone got another idea? Something simple. What would be the next thing I might want to ask it?
How to create it.
That's getting one more step ahead. What I'm going to do is ask it, what are good examples of it? Give me some good examples, right? Because then once I get a good example, then I can tell it to create that example. That's really good. Thank you for saying that. So here's a few coming up that I didn't even think about. We could do logistic regression can be used to classify emails as spam or not spam. See, guys, just by you're really getting into the real business case right away before we even get started. And it's going to explain it to you. Credit card fraud detection. Wow, I didn't know that. Medical diagnosis. Do I have cancer or not? Churn prediction. If someone's going to stay with a website or not. Heart disease prediction. Wow, there's a lot of things. I didn't see my iris. What about iris? See if it comes up here. The iris data set is a classic data set for classification. All right. And it's going to kind of give me some code there. And it's already giving me the code down how to do it. So then what I'm going to say, all right, so when I ask, give me good examples. Now, one thing you can do is this. You can tell it to give you a certain number of examples and you can get those. So what I say, I could went ahead and say, give me 20 examples, for example, and it would have given me 20 examples, and most likely my iris will be in those examples. Breast cancer, customer churn prediction, heart disease prediction. I'm gonna keep going. Loan default, bank note authentication, mushroom classification, employee attrition prediction, stroke prediction, Parkinson's disease prediction, wine quality, electricity theft, social network, hepatitis, default, adult. See, there's tons and tons. This very simple logistic problem can be used for tons and tons of different things I've never even thought of until I started putting in some prompts. I'm not going to find this in a book anywhere. But suddenly I'm just become very fascinated with just a simple use of logistic regression. And that's kind of like brain-based learning. I'm really getting excited about what I'm doing. So with that said, we'll go back to the iris example. And now we can go create. So create a logistic classification system for iris. Okay. And create okay, and that's one. So that will give me the Python. So let's put that in. And I didn't even have to finish my sentence. I'm using something called queuing. And so what queuing is when it comes to prompts is that if I say the word join, what does that mean? What kind of language do you think I'm talking about if I use the word join? Anybody know? What kind of language is that?
SQL.
Absolutely. These systems do the same thing. If you just put a few words in there, it actually immediately cues in on what that is. So I could put that in there and I could go, okay, it's going to create that iris system for me. All right. And it's going to build it out for me. And then once it builds it out for me, I actually want to be able to interact with it in a software system. And that's going to use the Streamlit interface that allows me to interact with the Streamlit interface. So the next thing I'm going to ask it to do is put a Streamlit interface on it. And then you see what you're doing is you're building a minimal viable product and you're stacking it. So you add this and then add that and then add this and then add that. And so those you start out with a basic product and you start adding to it. And if you're an agilist, you love something called refactoring. And you just start refactoring the system until it gets better and better. And you want to test it along the line. Now, I'm not stopping to test it here, but I am just showing you how to prompt engineer it. So next thing I would say, well, put a Streamlit interface on it with the appropriate inputs and outputs. And then I'll just let it crank away on that. And that's just the example of where we're at. That was exercise 2. But you guys did good on that. So we're going to move forward with that. I showed you the system that it created. It was pretty amazing. And then just I want to give you guys some resources if you want to learn more about Python TensorFlow. So let me go ahead and put a link in the chat. There's lots of courses you can take here to learn it, but I'm going to show you a different approach to learning using these same resources. So let me put that in here in the chat. That's a great resource if you want to come up to speed on machine learning. You can go through all these different courses, but I'm going to suggest that you go through them in a different way. So one of the courses I suggested on LinkedIn, which was really great, was the crash course on machine learning. Here it is right here. So if I go to that crash course on machine learning, let me do that. The way I used to do it is I would start the course and I would use the outline and I would go through it piece by piece by piece. But I'm not going to do it that way anymore. What I'm going to do, I'm going to come along here and I'm going to take a snapshot of that course. All right. And then I'm going to go back to my chat system and bring this down. And I got to go grab the snapshot. That would be a chore finding it. Give me a moment. I do not know why I'm having difficulty finding my snapshots. Let me see here. Let's see, where did that snapshot go? All right, I think I got it. Matter of fact, what I'm going to do is, I believe I've already taken that snapshot. Here it is right here. I'm going to go ahead and copy that. I'll use that instead. I'm having a problem finding it on my desktop. So I'm going to copy that. That's the copy of the course. I'm going to take that in here and I'm going to paste it in. Right? And then what I'm going to do, here's my prompt. Create this class for me with an emphasis on hands-on exercises. That's right. I'm going to have it create the course for me. Just paste that in and it puts this extra in. You get rid of it and you're going to run it. And now it's going to build that course for me. And what I'm going to do, I'm going to do this course and it's going to give me somewhere to hang my hat. And when I go now to do the other course, I'm going to be ready to go because I've already worked through all the code, but I did it by pulling knowledge. Oh, this is fascinating. This is interesting. What does this mean? What does that mean? Now, I want to tell you, this is a lot different than what we got when we were in elementary school. Now, if you remember in elementary school, when they first handed out the textbook, I can't forget it. I was, it was in 2nd grade. They handed out the textbook and the teacher starts teaching from the textbook. And I'm so fascinated. I'm moving the pages forward. And teacher says, stop moving the pages forward. Stay with me. Really? It really killed your curiosity. And using this pull method, you turn your curiosity on. And in a sense, you become a virtuoso and you just start coding. That's what you start with. You don't start with watching a video and then trying to figure it out. You just start with by doing and pulling and using your fascination. So that's kind of the end of that right there. We're going to move on real quick and talk about TensorFlow in the browser. But before we do, I want to ask you guys, are there any questions so far? Now, I'm going to learn about TensorFlowJS. Why am I interested in TensorFlowJS? Because it gives me the ability to run these experiences in the browser. Okay, so right now I'm running Python. On Python, I'm putting Streamlit, which allows me to expose it to the browser, but it doesn't give me the full power of the HTML JavaScript browser. About 80% of code out there is being done in HTML and JavaScript, even if it's running on a mobile. And so you can do that using the TensorFlow.js, and you actually can pull models from TensorFlow.js. And so here's a list of models, and I'm going to grab these and put them here, of models, TensorJS, and we're going to actually look at some today. So what is the first prompt that I'm going to put into the system? And that's going to be, what is TensorFlow.js and how might I use it? This is my first prompt. You know, just starting at the basics, tell me what it is. And so I'll bring up my ChatGPT, and it's going to tell me what it is. So TensorFlow.js is a JavaScript library developed by Google for training and developing machine learning models in the browser. So what's happening is actually, the first thing it does, it downloads these models into the browser. So what we do now, if I need to talk to a AI system, I have to go up into the web server and pull the information down. But this downloads into the browser, and from that point, I'm not going into the web server anymore. I asked it what it was. It told me what TensorFlow.js was. And then I've got TensorFlow and it explains what it is. So now my next prompt is, you need to learn TensorFlow.js, give me 10 hands-on exercises, and create a class with these 10 exercises explaining each one. So once again, I'm going to create my class that I can learn from, as opposed to having someone else teach me or me learning from a video. So I put this in, all right, and I hit return, and it begins to crank out the class. Now the class is going to be a minimal viable product, in a sense that I'm going to not be happy completely with what I get back here. So I'm going to make some minor changes. It is giving me a class. It is actually giving me code for each element. And I want to experiment and crank through each element of this code on Hugging Face. All right. We got about 5 minutes here to wrap it up, and believe it or not, we will. So with that said, that was the first part of the course for me, but I wasn't quite completely happy with that. I actually want to bring exercises from the JS models. So there's a number of JS models out there that I can bring in. So I'll actually tweak this prompt just a little bit once it finishes up. And we'll just continue that. And we'll ask it to bring these models, these examples from the models themselves. Okay. And so now I'm tweaking the course a little bit. And with that said, there's one more tweak, and it's change, and you can change out an exercise. So if you don't like one exercise, you can change out another exercise. And so what I actually got at the end of the day was this nice outline with actually links to the different models that I would be using in my course. And if we'd had time today, we'd actually choose one of these and work through. But I want to show you one of these examples of JS in the browser. And so I created this right here. And this is Welcome to Transformers JS page. And it's an object detection system, and it's a pose detection system. And it's going to run in the browser. Now, this is actually running in Hugging Face. So let me go ahead and give you the link to this in Hugging Face. And it's my Hugging Face JS class. I only have 2 items in there right now. But let me go ahead and put this in the chat. And with that said, let's look at object detection. All right, there it is. There's my class. I hit object detection, and I want to run the webcam, and it's going to actually identify me as a person. All right. So if you've got a garden and you want to make sure and you're worried about people being in there at night, you can actually put this up, and it'll tell you if there's a person back there, if it's a cat or it's a dog or it's an animal, it'll identify. Okay. The next one I actually put as an example. So what's happening, it's actually downloading this into the browser, and it's running and identifying from the browser. Let me see if it will do a cup. Look at that. It's telling me it's a container. Isn't that funny? So it can actually distinguish the different things, all running in the browser. And I didn't write a single line of code here. Once again, this was all written by prompting. And so you can come down here and you can look at the HTML for that page 1. That's the HTML. And you can actually look at the script that was generated. That's the script for that one right here, right there. That's the script that that runs that. All right, cool. The next thing I want to do is take a look at my pose detection. Oh, I got to go back to, sorry about that, to the actual application. And I click on pose detection. And what pose detection is, it's actually putting it on my eyes, and actually putting it on my arms, and it's detecting my pose. This is amazing. All in the browser. Now, when the pandemic was raging, I actually used to do a lot of Zumba. So I got certified as a Zumba instructor. And they actually used something like this where you would dance and it could tell if you did the dance right or not based upon your poses. So yeah, a lot of applications here. And guess what? Is 4:56. And once again, all I did was prompt engineer this. I did not, once again, write one single line of code. I just told it what to build. And if you want to learn a technology, before you run and grab a video course or pay money for something, just prompt it and say, create a course for me. And then, use a system like Hugging Face and start building it out. And, going step by step, you'll be amazed at how easy it is to do this type of work. So with that said, to go back to the index, as the two examples of Transformer.js, once again, it's pulling these models down. They're running from the browser. Data's not going back up into the cloud. It's staying in the browser and local, so it's safe. It's not going out and being distributed somewhere. So that is the course for today. I know it was fast, but it's really important stuff. And I know you probably didn't see what you thought you were going to see today because the technology has changed. And believe it or not, I could have spent an entire course just going through one of these programs, or I can show you how to build all this stuff like in a matter of minutes. And so it should accelerate your learning and your excitement about learning. So that's what I had for today, guys. I'm open for discussion. I'm going to hang out and answer questions. I hope you enjoyed it.